Hello everyone, and welcome to the Geomative. There is a training about the mainframe. As you can see in front of me, there is a mainframe of our GD-10 series, and this is the GD-10 mainframe. As you can see, the appearance will be only the materials. We are to protect when you do the field works and for some protection work. And as for the mainframe, it have included the function as the resistivity and IP induced polarization and the SP method. And as you can see, this mainframe will have the screen in here and also have some connection in the left and the right panel. So later I will show you the details about the three parts. The first one, as you can see, is the screen. They will have the screen with a 5.7 inch, and it will be very convenient for you do the field works since it will be too large. And meanwhile, it is the color screen. You can use it in the field works, especially when there is a dark or some high brightness condition. And there is the buttons which were connected for the different function, and also it is connected the different procedures. And as for the left panel, we can see there have some parts which will connect to the mainframe and the cable and the connections. And the left panel, there is a part which will be connected the cable, the EIT cable, for the 2D and 3D resistivity method and IP methods. And there are also some electrodes with this transmitter and the receiver part. And these two parts will be the power input. This is the screen of our GD-10 screen system. There is a 5.7 inch, and with the color for the screen, it have the 618 plus the 415 with a higher resolution. There is 11 buttons, and with a spin buttons, it will can do the test with the create the tasks and assess the dates and export the data and the script to the mainframe. The F1 to F6 is to represent the different function in the screen. User can use these buttons when it's to remind it for the specific functions. And there is left panel with a 5 button, the page up, page down, menu, and back, and the brightness button. The brightness button will be used to adjust the different lighting of the screen. It will represent the function as to saving the power and protect the screen. The spin buttons, it will be used to do the scroll this option from the screen and choose in as the enter to as confirm. The left light of the screen is the warning light. There is 3 options: the red, the green, the blue. The red is mean the warning, and it will represent the machine with a different working conditions. And the screen is for the normal condition when we do the general test. And the blue means you will connect the GPS. Part 2. They connect the right panel of the mainframe. There is the panel with a million the ports. The first 2 is the power input and output. And the next one is AB with the transmitter. And the left one is the MM with the receiver. And the This next port is to the Earth. The fuse port is to protect the mainframe, and the left one is the ERT tester port, which can be connected to the ERT cable. So next we will do the example of the ED connection in the field. So the first is the power. We give it the modular power, and with the resistivity boxes to represent the Earth with AB and MN. So the connected results shown as below. Part 4. GD-10 Spring 2D and 3D ERT system. The mainframe for detecting the data, and the power BP145 for the power input, and the cable leader, and the airtight cable for connecting the cable and with the mainframe, and the ERT cable and the electrodes. Part 5. The system in the field. As you can see, there is electrode and the ERT cable. The electrodes connected with the ERT cable by the clips, and with this cable leader between the cable 1 and the cable 2. The colleagues, they are doing this cable connecting with the clamps connected with this electrode. So at the end of this cable, it will need to connect another cable leader as end. And this is the sense of the cable layout. We do this testing in the field. So when we connect another cable, also the same as the before, the electrodes connect with this ERT cable with the clips. And this the plate confirms the electrode in the field. We have the hammer and put it connected with the earth directly. The cable, ERT cable, connected with this cable leader. There is a red port. When you would do the connection with the cable in the cable leader, just put these red marks and the SIM that we can connect with. Also, we will choose the red marks. So one cable leader is connected well with this cable and the cable leader. The mainframe will be laid out in the middle of this cable. When you connect the cable leader, you need to put the remarks of the cable leader GD-10 with this mainframe. When you do the field works, you need to put the electrodes like this. With the electrodes 2 and 3 will connect it to the earth and put it fixed well. When it comes to some specific the field requires have lower resistivity and it's hard to put the current to the earth. When it's use some water to put it this connect well with these electrodes can be used the stainless steel materials. It will can connect with this ERT cable directly with these clips. You can see this port is from the ERT cable. It has the higher ranking with the IP65 to confirm this connection well connected. It will be used to connect with this ERT cable leader directly. The LT cable connected with this mainframe first. and the AB points will be connected with this right panel of the mainframe. The ports were connected with the cable leader. The ART cable is used to connect the ART cable and the mainframe. The other ports of the L-tap cable, it will be connected with this ERT cable directly. So there is two directions. It also can decide the thoughts about the electrodes when you do the test. As for these parts, this direction, open the mainframe. As the first step, we need to search the cable leader. Press the button as the cable leader is searching. The system will be searching it directly. There is a 4A cable leader we have connected, and the location will be shown. The L1 means the left, the R1 is being the right. We go to the project surface and do the 2D list for the 2D ERT tasks create. As you can see from this page, the task's name and the task's basic information we need to set in before the test. The text name, you can do it by yourself, and the project details. As for the method, we have two states, the RES2D. And the error the tabs will be winner, alpha, and there is 13 items for you can choose. As for this time, we choose the Slamberger as the error for the test. For this script, if you have some specific script, you can do it from the Geomative Studio. But the Geomative mainframe have the standard script. We always do it with the standard script. As for the electrodes, we have located the field with the 17 electrodes. So the mainframe will detecting the electrode one by one. So the start electrode will be 1, the end will be 272. But if you do the field just the layouts, the electrodes, or you want just to check that the electrode will be 16 or 17, you can do it as a remark. As for the layer of the system, if you choose the end layer will be higher, then you can get the mailing data. For the running along the function, that is a specific function. We will give the specific training. For the stacking, the stacking math, the function, once you choose the stacking will be 5. And that means all the data will be connected will be 5 times. And the spacing of the electrode, and for this type, which is the 1 meter. The simping the interval, we always get the default by 0. As for the step when we're doing the gradient R test, it is inevitably when the field we have a higher or large the resistivity. So when we can do this gradient R test and take it as some steps for reducing this resistivity and to make sure the current will be put onto the earth currently. Okay, back for the test. After we finish the gradient arc test, we will go to the real tasks. And their list is the several steps. And before we do the test, we need to open the power. And to make sure all the electrode, all the ports from the cable, from the mainframe, from this power were connected well. And we choose the value of the power as the transmitter power. When we've started this test in the field, we also can check the data in time. We choose the graphing port, and we see the data in the graphing port. As you can see, for the same section of the layer, the graph will be the same, will be the smooth. If there are some things occurred from the zigzags, then we need to check the data. And if we found the data was abnormal, we can continue the test. There is a list with the electrode and the specific this APM and the location and the resistivity and the voltage and the current. This is the curve about the voltage and the current. We can check this curve from the different electrodes connected, since this will be a way to check the data accuracy is good or not.